from the reputed concern Vailtech Rangarajan, Dr. Shakuntala, R&D Institute of Science and Technology, and with the blessings. Yes, ma'am.
Switch on your video.
Ma'am, can you hear me?
ma'am?
Ma'am, can you hear me, ma'am?
Yes, ma'am.
Yes, ma'am. Shall I start, ma'am?
Switch on your video. Camera.
Okay, ma'am.
Nivedika.
Okay, ma'am. Good evening, everyone. On behalf of School of Computing from Vailtech Rangarajan, Dr. Shakuntala, R&D Institute of Science and Technology, and with the blessings of our founder, president, and chancellor, Professor Dr. R. Rangarajan, sir, and our founders president, Dr. Shakuntala Rangarajan, ma'am, and our chairperson and managing trustee, Mrs. Rangarajan Mahalakshmi Kishore, ma'am, and our vice chancellor, Professor Dr. Rajat Gupta, sir. I, Mrs. K. Nivedika, Assistant Professor of CSC Vailtech, welcome you all for the online 6 days faculty development program on enhancing cyber threat detection through incorporating digital technologies, sponsored by All India Council for Technical Education, AICT, New Delhi, organized by the School of Computing, Department of Computer Science and Engineering, Vailtech. We are fortunate to have with us today Dr. P. Chandrakumar, Dean, Industrial Relations, TBI and R&D, Vailtech. Welcome, sir. I'd like to welcome our registrar, Dr. E. Kannan, Professor of CSC Vailtech. Welcome, sir. Also, I'd like to welcome our conveners, Professor Dr. S.P. Chokolingam, Dean, School of Computing, Vailtech. Welcome, sir. Professor Dr. V. Dilip Kumar, Associate Dean, School of Computing, Vailtech. Welcome, sir. Then I'd like to welcome the heads of the department, Dr. N. Vijayaraj, Professor and Head CSC Vailtech. Welcome, sir. Dr. M.S. Muralidhar, Associate Professor and Assistant Head CSC Vailtech. Welcome, sir. I'd like to extend my gratitude in welcoming our faculty coordinators of this event, Dr. S. Amuda, Professor CSC. Welcome, ma'am. Dr. N. Malarvili, Professor CSC Vailtech. Welcome, ma'am. Along with the organizing committee, Mr. N. Shivaramalingam, sir, Mr. G. Rajesh, sir, Mr. K. Prabhakaran, sir, Assistant Professors of CSC, along with Mrs. A. Lizzie, ma'am, and Mrs. K. Maitri, ma'am, Assistant Professor of CSC. And along with us, we are much delighted to welcome the various faculties and research scholars from various institutions to join us today for this wonderful occasion. I encourage all of you to actively participate by asking queries and make most of this opportunity to learn and grow. Thank you. Now, I'd like to call Dean R&D to give inaugural address. Sir.
Actually, sir is in meeting, so you can call our dean, sir.
Okay. So now I'd like to call our Dean SOC, Dr. S.P. Chokalingam, sir, to give special address about this FTP. Welcome, sir.
Dean, sir.
Yes, madam.
Kindly give an inaugural address, sir.
Yeah, very good evening to one and all present here. I think it's a very happy occasion. I'm inviting for all presenting in the online session. So as a Dean SOC, I'm welcoming you for the ACT sponsored Atal online 6 days faculty development program. So this FDP, the thrust area is advanced computing and cyber security. So this program, I'm assuring 100%, this programming will be much helpful to understand and enhancing the cyber security threat detections and generally incorporating with the digital technologies and all. And here we are covering all cyber security. cyber threats, and generally the fusion of machine learning with advanced analytics and real-time digital technologies. All we are covering the area, and moreover, these sessions we are a productive and inspiring session, especially into that the machine learning for anomaly detection we are covering, and fundamentals of cyber threat detection, and digital technologies of cyber security, and NLP of cyber security, big data analytics in cyber threat analysis, predictive analysis for cyber security, and AI for threat intelligence, security and event management, blockchain technology for data integrity, solution for real world problem in cyber attacks, DGA driven botnet detection algorithm, cloud security solutions, case studies, and practical application on MI, ML, and all the emerging and very much important into the research area which is to be covered. So we have a excellent eminent speakers are available for this session, especially to the Dr. J. Shibarani Madam. So Dean Associate, I'm welcoming and my sincere thanks for presenting the Atal FTP. Shibarani Madam and Priya Matters and Krishna Kumar and Dr. S.P. Raja and Dr. S. Bhuvaneshwaran and Meenakshi Chaudhary and Anita Rani and Dr. T.P. Reshmi have a wonderful speakers are all participating, and this session must be helpful for you to understand the machine learning and cyber security, threat detection, and all the thrust areas. And my sincere thanks to our faculty and coordinator, Dr. S. Amuda Madam and Dr. Malavili Madam. I think you are doing an excellent job. Okay, with your great effort, this FDP started in a very good way. So, moreover, I am 100% I'm assuring this all 6 days FDP been a very useful to everyone. And once again, I'm welcoming you and thanking you for all attending the workshop. Thanking you all.
Thank you, sir. Now I'd like to call our HOD, Dr. N. Vijayaraj, sir, to give a few words about the FTP. Sir?
Yes, ma'am. I'm audible.
Yes, sir.
So good evening to one and all present in the present evening. So it is my great pleasure privilege to welcoming for the AICT sponsor 6-day Atal FDP on titled on enhancing cyber threat reduction through the incorporating digital technology. First of all, I would like to our thanks our management, Dr. Rangarajan sir, and with the blessing of Dr. Samudala ma'am, our VC Dr. Rajat Gupta sir, and Registrar E. Kannan sir, Dean Dr. Jokolingam sir, Associate Dr. Dilip Kumar sir, and Dr. Muralidhar sir, and head, and today chief guest Shiva Mary ma'am. And also I would like invite everyone participants of this today event. Our presence is important for the FDP, and we are grateful our participation. Over the next 6 days, we will deliver into the latest development trends and innovation in the enhancing cyber threat detection through the incorporating digital technology. So our Atal FDP features impressive, eminent speaker from national and international level speakers we are arranged here. The trust across the industry and across the organization and Nivedika, ma'am, I am audible?
Yes, now it is audible, sir.
Okay, ma'am. So we believe that the event will be provide the valuable platform for knowledge sharing and collaboration and growth. So before begin, I would like to acknowledge our hard work of the coordinator and the organizing committee who have tireless effort for this workshop successful manner. So once again, I welcome you all for the by this evening FDP. So thank you to all.
Thank you so much, sir, for your wonderful words. With no further delay, now I'd like to call upon our Assistant HOD, Dr. M.S. Muralidhar, sir, to give few words about the FTP. Sir, welcome, sir. Sir, Murali, sir.
Muralidhar sir. Sir.
Murali, sir. Murali, sir. Murali, sir.
Actually,
He's leaving.
a network problem, I think.
Join.
Muralidhar sir.
Ma'am, am I audible now?
Yes,
Yes,
sir.
sir.
Yeah. Sorry, ma'am, there was a technical glitch from my end. Yeah, I'm very much happy to make sure that I'm one of the organizing people of the ATEL FTP that has been conducted by our School of Computing. So, as per the title says, the digital technology. So, we always refer to the digital technology as the tool or the system that makes sure that we create, store, and process the data. So here we are going to focus on the two main aspects, which is our cyber security, and we are going to make sure that we analyze and identify the threats that are there, and to make sure that we are in a position to avoid those threats. So our FTP will be focusing on these kind of platforms where we have many eminent speakers from all over the world, and we have the session that has been running around for 3 hours. So make sure that you have a complete participation of all the days and have a very good insights on the speaker's knowledge, and make sure that we have gained a secured knowledge on cyber threats detection through incorporating digital technologies. And I also thank all the participants who have joined us today for the inaugural function. And followed by, we'll be having the sessions from 6 p.m. to 9 p.m. On all the days from tomorrow onwards. So make sure that you attend regularly. And after pandemic, we are all used to the online sessions. So there'll be certain glitches, but still we'll make sure that we render the complete streaming continuously and in a very effective manner. And I also thank our faculty coordinator, Dr. S. Amuda and Dr. N. Malarvidi ma'am, who have come forward in organizing the training and learning program for 6 days for enriching the faculty's knowledge in the latest trends of cybersecurity threats. And I also thank our management who have rendered their support in making sure that we can arrange these kind of, we can organize these kind of training and other activities to various educational community people to make sure that we are also a part in the developing trend. I thank our Dean Sir who have given us this platform and who has accepted our invitation to make sure that we have a kind of upper hand to make sure that we develop and we create these kind of online training programs in the near future also. Thank you so much.
Amuda ma'am, you're audible. Amuda, next session.
Yes, sir. Next session is handover to Maithili, ma'am. Resource person is joined, sir.
Okay, okay, ma'am.
Actually, she is ready to handle the session. Maithili, ma'am.
Ma'am, am I audible?
Yes, yes.
Okay. Good evening and a warm welcome to everyone. I take great privilege to introduce our esteemed resource person, Meenakshi Soundri ma'am, who has graciously accepted our invitation to share their valuable insight and expertise with us today. She holds BTech IT and have remarkable 14 years of experience in IT industry and achieving outstanding success throughout her career. She has technical strategic experience with proven record of accomplishment in development automation and operation coupled with people and thought leadership. Her key focus areas are Tech Women Steering Committee, diversity, equity, and inclusion, project management and delivery, strategic planning and return on investment, new product development, AML Center of Excellence, GitHub Copilot adoption. Throughout her 14 years of career, she has navigated various roles with ease and excellent beginning as software developer, project leader. She rapidly progressed to project manager, senior tech cons, people leader, senior engineer. Today, she continues to excel as developer, consistently delivering high quality solutions. Please join me welcoming the Meenakshi Soundri ma'am for enlightening the session. Thank you.
Thank you. Good evening, all.
Meena, ma'am, one second. All the participants are requested to switch on your camera for photo session and then we start the session.
Yes, all will.
Okay. Okay, ma'am, please you carry on.
Good evening, all. Thank you for the great inaugural session. And thank you, Amruta ma'am, and all the coordinators for having me here today. I mean, as mentioned in my introduction, I work as a director in Comcast Technology Solutions for software development and delivery. That's my core role. I mean, in my, I'll connect my topic to how I actually basically it relates to my professional world. Okay, so earlier in the days when I start as a developer, we do write like lot of codes. It's like every piece, every functionality that we see in the user interface, it is like it has to be coded. That's how the initial days of the development has been. I still remember this COBOL Pascal, wherein it was like tons and tons of lines of code. That's how it has been, right? I mean, folks, you can hear me good, or can you hear me good? Can one of you confirm if my voice is good?
Yes, sir. Okay.
Good. Thank you. Okay, but now the industry is actually marching towards this AI ML. This has been like a topic. I believe majority of you are from college or the faculty members, but how it is trending over there, it is trending in the IT industry also. I mean, I have 2 decades of experience in the IT industries, but we could see like a fast pace of growth in the AI ML in the recent days. And to my surprise, not that in the college, nowadays, even in the school, they have started this artificial intelligence. I mean, my daughter is in 11th grade. When she was in 9th grade, she started to have this artificial intelligence paper. I mean, they said like that's not like a mandate paper, but her school adopted that. So I went to check with them how are they planning to coach them, because are the staffs equipped enough with the latest technologies, because there in the IT industries we are all learning day by day. Believe it or not, it's like a continuous process. As you do in the college, in the industry also, we are learning it day by day to adopt the best practices that will help our processes easier. All the automations from a product standpoint, from a process standpoint, we are also learning. So that ma'am in my daughter's school, she told me like, yes, they are also learning because they have like an external coaching facility or something. With that, they learn, and then they in turn actually ask the students to learn. And I used to read my daughter's artificial intelligence book. Um, to them, it is all very simple. It is like this is how the computer life has been. But then for us, it is like it's a lot, right? I mean, sometimes I even used to wonder the miracles this AI and ML has been doing. Um, can any one of you, maybe you can type in chat as well, some real-time examples of AI/ML which we use in our common day-to-day life? Any common examples of AI/ML? Yes, exactly. First thing, thank you, Kanimoli ma'am. Chat GPT, YouTube recommendations. That's right. Google Assistant. That's true. My background? No, my background is not the AI/ML because I have selected it purposefully. I mean, I actually wanted to create some wallpaper with your FDP, faculty development program, and then keep it so that it will be more meaningful. Google Maps, that's correct. Personalized learning, that's correct. Yep, Chat GPT. Let's first go with Chat GPT, right? When the Chat GPT gets evolved, there are pros and cons with AI/ML. I'll definitely say like uh, the usage of Chat GPT when it started in the industry, there were questions in the IT side saying like whether people will lose jobs. And we said like, no, it will not be the case, because it will, we will be trained enough to how to use Chat GPT. And many organizations are not allowing engineers to use Chat GPT. But one pattern I have observed in this Chat GPT is like it's slowly stopping us making think. Okay, it's how, I mean, all these of course you all know the digital technologies. All these is how we use it, how we adopt it. Making the best out of it is what the usage of it, right? It can turn towards bad as well. I mean, I see many students are using Chat GPTs to prepare their assignments essays, everything is becoming easy with ChatGPT. But if we start using that a lot at that age, then how our thinking will be. I mean, I have recently seen in a movie wherein there was a dialogue like, people are making machines as human knowledge, human as machines, interchangeably, and we don't know why this is happening. But that's the downtrend of AIML, I'll say, like, but there is no other go. This AIML, if you see the history or the evolution of AIML, it's not like new, which has emerged in this recent trend. As you may know, it has been early in the 1950s, 1960s itself. We have like a lot of AIML practices, but now why it is trending so much? Why it is important? As many of your faculty members have mentioned in their inaugural speech, it is very important, like, because there are two pieces, like this data nowadays, how much our data we use is huge. It's, I mean, I'm from this network engineering. My team predominantly deals with the broadband networks. Okay, I'm responsible for that broadband networks right from the head end till the customer premises equipment, and we see the traffic data flow. If you think some 10 years back, are we into this digital world this much? No. Nowadays, everything is digital transactions, and then the flow of data, the what we say, it is upstream and the downstream of data. That's huge. That is actually making this AIML popular, because it is more like the logic, maths, and logic, and then pseudo algorithms, and the data. That is what, if you go through this AIML, that is what it is all about. Without this, it cannot be. I mean, in my days of college, data is what is data? Data is a meaningful information. That is like a important one mark. I still remember the college days. Okay, but now data is everything. Data insights, data visualization, data processing, that is all making this AIML as an inevitable part in every industry. I'll say, like, it's not just the IT industries, it is like every industries for which IT team is doing the solutioning. We are doing the solutions, and you people are training the folks. When they come into the IT industries, they can make solutions. That's what is on the core about AIML. Yes, Alexa, Cortana, Alexa, Siri, everything, I'll say, like, it's based on AIML. And then the recommendation someone has mentioned, like, so the product recommendations, earlier we used to say, like, even walls have ears, right? Now all our devices have ears. Whatever the electronic device, I mean, the smartwatch, it may be listening to me. The Alexa, it may be listening to me. I mean, I have like a Google Pod in my kitchen. It listens. I have an Alexa, it listens. So sometimes when in the family, when we make conversations like, okay, probably we should do some travel, and then in the smart TV, next time we'll have, yes, TV, even TV, it'll give the recommendations based on that. So I mean, in Comcast, we have this advertising division also. So in the advertising division, the predominant work of those engineers is to generate advertisements based on the people's interest. So how do you know that the people's interest is the data, right? So everywhere, the data is what is the main thing. So with that, I will now start the session. So far, I was giving one introduction. Okay, let me share my screen. Yes, Spotify music recommendations. And it is interesting, like sometimes it will say, like, probably this is what you would like to hear. Amazon, if you watch this movie is this, and then we are also giving data, right? Do you like this movie? Sometimes we say, like, and then there will be like a lot of labeling associated with each of it, with which the model will be trained, and we will learn about it, the supervised learning, unsupervised learning. Okay, let me share my screen. Okay, can you folks see the presentation? Can you folks see the presentation I'm sharing? Can one of you please confirm? is visible. Thank you, ma'am. Let me go to the slideshow. So today the topic we are going to, and I mean the next 6 days, the topic which you are all going to, maybe you are all well versed in it or enhance, I'll say, like, because there are a lot of PhD members here that make me a little nervous. Oh my God, so many people, so many learnings you have did. We are all doing learnings for our professions, for the work which we are doing for the projects, but you are all doing the learning to make others learn. That's truly tremendous. I'm trying to switch to slideshow mode. Okay. Okay. And if there is any feedback, please unmute yourself and speak. I'm in the presenter mode. I may not be able to see the chat window unless I go Alt tab. Okay. Yes, it's visible. Okay. Okay, so this is what we are going to do today. Understanding techniques, applications, best practices, some case studies. I believe I'll have time for case studies. I actually wanted to make you all do some case studies, but in the interest of time, I have prepared some pointers that will give you a little more clear picture. Points to remember, resources and further reading. Of course, you all love reading, I could see. And then questions and discussions. Questions and discussions, if we do not have time, I may take it up later as well. Amuda ma'am has my contact. And to me, this is a skill I acquired. I mean, I acquired in the sense of this of the learnings which we have to do based on our projects and the delivery requirements. Okay, first thing, AI versus ML. So this is another key thing, right? In this two terms has been used interchangeably all the times, AI and ML, AI versus ML. But what exactly is the relationship between AI and ML? So AI is a technology, it enables machines to mimic human intelligence. Like, see, when we say human intelligence, it enables to mimic learning, problem solving, decision making. Okay, but so here it is all max. I mean, today I read one thing like the father of AI and who are all like the introducers, and I could see like majority of them are the ones who have excelled in the mathematics. And then this is another reason some people start AI and ML learning, but they will not be able to continue because in earlier days they wouldn't have loved maths that much. Okay. So, and the examples as we see, it includes smart assistants, robotic, and even the self-driving cars. Those are all examples of AI. And machine learning is a specific application of. Yep.
So kindly make it in slideshow mode, and your slides are also not changing. We are seeing only the title slide.
Oh, you're not seeing it? Oh. Sorry, ma'am. Let me try again. Yeah, I'm into the third slide almost. Let me try it. Thank you for the feedback. Try to entire screen. How about now, ma'am? Can you see the agenda?
Yeah, okay, ma'am. Yes, ma'am. Yes, ma'am.
Do you see it is in the presenter view or the full view?
It is in full view only.
Full view only? Okay. Okay, so you see the agenda slide now?
Ma'am, it's in the presenter view.
It's in
not in the full view.
Okay. Should I slide?
Now we got it. Ma'am.
Now it is clear. Full view. Title slide we are seeing.
Title slide you are seeing. Okay.
Meena,
Yes, ma'am.
the slide not changed, why?
Yes, ma'am. I'm still. I mean, I've stopped sharing. Slides. Anyway, ma'am, you have your hands up. Please give me a moment. Sorry for the trouble. Hope you folks can see the agenda slide now. Can you folks hear me, please?
Yeah, yes, ma'am.
Okay. So it's in the full view now, right? Is my screen in the full view?
Yes, ma'am. Yes.
Okay, okay. Thank you. Okay. So, yep, A versus ML. This is the slide I was talking about. So AI it enables the machines to mimic human intelligence, but then machine learning is a subset of AI. Okay. So here if you could see, artificial intelligence means creating smart machines to mimic human behavior. That's the whole set. Okay. In this, machine learning is a subset of AI and it builds a model based on training data to make predictions. But then there is another concepts, like I think there are some sessions planned on the deep learning and deep learning as well, I believe. So deep learning is a subset of ML. Okay, it involves, so one best example I'll say, like ChatGPT is a best example of deep learning, wherein you will have multiple layer neural networks to learn with available data and make decisions and predictions. Okay, so that's what is deep learning, and it is a subset of ML. But data science is a subset of AI, wherein here this data learning, why it is actually near deep learning, it's like it uses deep learning optimally to identify the patterns and trends in bigger data sets. That's what is data science. And then we have like the visualization also based on the data science. Okay, now what is machine learning? So we have learned about it and the applications of machine learning. So in the introduction we were talking about, right? So the different real-time examples of machine learning. So it uses automatic language translation is an example of machine learning. We have like a lot of translators now. People can even travel to overseas. I mean, of course, English is not the only thing they have to know. If they know to use the language translator, because when we send folks to different parts, like there are actually countries wherein people are not that fluent in English, and sometimes the UK accent is a little hard to understand. So at that time and all, the first coaching we give to the interns or the college hires is like they have to get familiarized with the accent. But then for that, the first step is they can turn on the live captions in the Teams, and then they can use this language translator, even the accent detector and all those things, which are all the machine learning models. Okay, and medical diagnosis, in the medical field, there had been like a lot of research that they were able to do using the machine learning. And stock market trading, so this and all, it's like again a threat. But then stock market trading here, I'll say like it is based on the visualization. It can read through a lot of patterns. Earlier, if you see like this Wall Street, and if you could relate those old Harshit Mehta and all those things and all, there will be like a papers, tons of papers and news collections wherein people who are trading in the stock market used to read and then make predictions. But nowadays, to about the readings, machine learning is helpful. That's what I'll say, like an online fraud detection. So this we will cover majority in the cybersecurity session. It is again this anomaly detection comes in this, right? So the cybersecurity, online fraud detection and virtual personal assistant, this Alexa, Cortana and all those things, email spam and malware filtering. See, every company now has like a separate cybersecurity division. That is another trending thing, I'll say, like, and then I really have a lot of interest towards this cybersecurity, and how they train the models is based on this machine learning, because we get like a lot of emails. I mean, this laptop, I'm actually using it after a long time, because I am used to my office laptop, but I'm not supposed to connect to a meeting from outside meeting from there. That's what this juggling is between. Because the cybersecurity has got like a lot of solutioning in their place, wherein they'll be watching which one we are doing and then what email, and then we can report the spam, we can report the malware, everything based on this machine learning. And self-driving cars, product recommendations, this we have discussed, traffic predictions. Okay, in the Google Maps, someone has mentioned, right? In the Google Maps, the travel predictions, speech recognition, image recognition, all interesting stuffs, right? I mean, in the Google Photos, there are like a lot of interesting stuffs based on this image recognition. And we do this at Comcast, we do this streaming of video streaming and there and all. There are like, I mean, we conduct like once, twice in a year, we used to conduct this lab week and the hackathons. Okay, so there predominantly we are getting options based on this image recognitions. Based on the image recognitions, what are all the things we can actually unveil? I mean, I'll say you one example. We presented an idea saying like, see, from an agricultural perspective, it is not just towards IT industries. In an agricultural perspective, the locusts, how we can actually using the satellite images, how a farming can be developed, that like this forecast of this locust, that this is how this may affect the crops. Of that, there was one employee who did an image recognition, but that we translated into a telecom project. But all those are based on machine learning. Okay. There are 3 types of machine learning: supervised, unsupervised, reinforced. Maybe I should go a little faster. It is again 7 o'clock. Ma'am, I have time till 7:30 or 8, ma'am.
6:30 to 8, Meena.
Okay, thank you. Okay. Okay, supervised learning, unsupervised learning, reinforcement learning. So in supervised learning, a model learns to predict the future based on what has happened in the past. So here we'll have historical data with ground truth labels. Based on the previous occurrences, the data feed itself will be based on the labeling, like 1, 0. It will be like it needs a manual intervention as well when we initially start this approach. But then unsupervised the learning, the model attempts to understand what has happened in the past, so it can itself classify the future outcomes. So here, wherein we don't have the ground data available, unsupervised learning can also be used. Reinforcement learning is most on a trial and error approach. We recently used a reinforcement learning for one of our project, and then but then it will generate an output, and based on the one thing is like whether this is useful, this recommendation is useful. Sometimes in the decisions, even in ChatGPT we get this, right? And then sometimes we regenerate the outcomes. So it is decision making algorithms is constantly refined based on the rewards. So when you give a like, it is like, okay, this is correct. So it will keep learning itself, and based on the feedback from the user. And always feedback is a main thing in the machine learning. How the models train is based on the feedback. So that we will see in the case study. Okay. Machine learning processes. And before I dive into that, so based on the problem we are trying to solve, we need to consider some additional factors like amount and quality of data, and then what is the application and what is the derived outcome we are looking for, and the available resources as well. So there are like a lot of algorithms, but then how it will be determined is based on the resources we have, and then interpretability. If there is like a decision making that the model can make, based on that only we will be determining whether it is supervised, unsupervised, or reinforcement. And the 7 machine learning processes, this is how generally all the projects will be. It is like the data gathering, the first phase, and then the data pre-processing. Just first to identify and then pre-process the data, and then choose the model. There are a lot of models available, and I will try to cover a very basic thing of each of the models. But then because each of the models in turn will be like in 45 minutes or 1 hour sessions, and the programming associated with that is even more. Yep. And then to train the model. After that, test the model, tune the model, keep giving inputs, and then the prediction out of it. So we have seen it in the what movie called Indiran, right? So first it is to train the model. So there you could see like then every book it will scan it. So that's how it is reading it. But generally in program, then the algorithms it itself trains it, and it has to be tested, and based on the outcomes it has to be tuned, and then only it will give the prediction. Okay, now to our topic of anomaly detection. What is an anomaly? Anomaly is that doesn't matches with the expected behavior. That's an anomaly, right? This is the expected behavior I'm looking for, but if it is deviating from it, that is called as anomaly. And what is anomaly detection? It is in data that do not conform to the expected behavior. So in machine learning, we have to train the model with the expected behavior so that it gives us the non-conformance behavior. Why it is important? Because it is important for us to mitigate the risks and improve the decision-making processes. It's not only for mitigating the risk, it is also about enhancing the customer experience, I'll say like. Okay, it is significant in applications like fraud detection, network security, predictive maintenance. See, for every product now to be live in the market, this is important. The customer satisfaction is important, and how secure that is important, because if everything is digital, right? And in the network, when a packet travels, there are a lot of norms, lot of guidance associated with it, and so even a slight deviation, there is like a lot of things towards hacking, which you may get to know in the upcoming sessions and all. So for all those, this anomaly detection is the key. It identifies suspicious activity that falls outside of our established patterns of behavior. Okay. The solution protects your system in real time from instances that could result in financial losses, data breaches, and harmful events. So data breaches, as I was mentioning, right, I'm not supposed to use my office laptop because of this data breaches. We do not know. And the reason for many companies to ban the chat GPT is because of the data breach that it could potentially incur. I mean, in the 6th day, I have like a session called solutions to the cybersecurity problems. So there I'll be covering about this data breaches as well. So overall, the goal is to enhance the decision making and mitigate the risks in real time. That is what is anomaly detection. Okay. Type of anomalies. There are three types of anomalies: point anomalies, contextual anomalies, and collective anomalies. Point anomalies are like such as it significantly, the data points are significantly different from the majority, like a sudden spike in the network traffic. That's one example of point anomalies. And then contextual anomalies is during a specific context. In this context, this is okay. Collective anomalies, a collection of related data points that deviate as a group. So distributed denial of service attack. So I'll say you an example of distributed denial of service attack. When this issue of this cyber threat, something happens, we used to generally group it. It will be like, I mean, recently we had this CrowdStrike outage. I'm not sure how many of you are aware of that CrowdStrike. It happened some 2-3 months back. Okay. So, but then that's a technical problem associated with the software. CrowdStrike is a protection software that we install. But then whoever has, I mean, whichever the servers, we have like a lot of applications and lot of applications runs on different servers. There was like, in the morning when I reached office, I get to know like some of the employees' laptop, they are not able to log in. And then I was mentioning like probably go and check with the IT support desk team. And slowly it was like I was getting some customers reporting saying like this application is not working, but the same people, they are able to access another applications. So we were not able to first understand what the problem is like. Then we started to group it together, like, okay, who are all having impacted and which are all the servers, what is the commonality of that server. And by that time, the global outage was announced, and it was like this, some updates that has happened in the CrowdStrike that has caused the problem. And then it is like, and then we started sending the email to the user community. Ma'am, is that to me? Ma'am, is that a call to me?
No, ma'am, it's not for you.
Because I hear some kids.
Yes, that is noise only. That is some.
Okay. So when we started to send the email to the users, we drafted it. We even drafted that in one person's laptop. But immediately after he was about to send it, considering all the impact, it was like shutdown. That laptop shut down. So it was like slowly impacting. So that's like a distributed denial of service attack. and then we identified the pattern and we managed to send those. That's the thing. So that's where like it is like one distributed cloud computing devices that will get impacted, or a distributed network that will get impacted. That is the collective anomaly. Okay, so anomalies as well. There are three types: supervised, unsupervised, semi-supervised. Okay, supervised anomaly detection. So here it uses labeled data to train a model to recognize the patterns. So this approach is often used for classification and regression tasks like weather forecasting, spam detection, and sentiment analysis. Unsupervised learning, it uses unlabeled data. So this is similar to what we have learned in the machine learning types. Okay, so this approach is often used for exploratory data analysis and clustering tasks. And customer segmentation. Semi-supervised, it uses a combination of both labeled and unlabeled data to train a model. And it helps to improve the accuracy and speed of the machine learning algorithms. And these are all different types. The examples of the unsupervised anomaly detection algorithms. So this I will try to cover it on a very high level. But then if you want to make a note of the algorithm names. So every big project or the hackathon project we take up, right? So that's the first discussion about will be the algorithms. There will be like a group of senior engineers or the from a center of excellence team that will be the discussions, and that will be the thing predominantly people will be reaching out to us. Okay, and why use machine learning for anomaly detection? Because it easily identifies and patterns. No human intervention needed. Of course, with the quantity of data it possesses, we need to go for ML because they can handle multi-dimensional and multi-variety data. But compared to that, what are all the challenges? Because the data imbalance anomalies are rare compared to normal data. So here it is like sometimes it may be like inadequate training data, poor quality data, or overfitting and underfitting, monitoring and maintenance. Even if it is a model, sometimes it gives the data what exactly it is. It will, if you look for some specific examples, it will generate the same things that I have seen in many machine learning models as well, because it's probably not tuned enough. That's one thing. And then there was not like the previous data available. And some common algorithm types and supervised random forest, SVM for binary classification. So this is what we have seen it in that first slide. An anomaly detection algorithm techniques to know: isolation forest, local outlier factor, robust covariance, one class support vector machine SVM, one class support vector machine. It's a spelling mistake, I believe. Stochastic gradient descendant, K-means clustering, long short-term memory, angle-based outlier detection. So these are all the popular anomaly detection algorithms. But what is an algorithm? It's a set of instructions that machines can follow to achieve a goal, right? And the techniques of the each of the algorithms. So as I mentioned earlier, each of this will again be like a 45 minutes topic. I'm honest, I'm going to cover it on a very high level. I have used in my teams have used only very less of it. SVM we have used it in one project. K-means clustering we have used it in one project. Isolation forest, there are some mechanisms that are going on. Okay, but I'll try to cover it on the high level. So in the isolation forest, it isolates the anomalies by randomly partitioning the data points. It will be like a tree kind of structure. So if there is like a data coming in, if it is a valid one, it will be like it will fall into one space. It will keep classifying it. There will be like first set of classifying into subsets, and from that subset into multiple other subsets. So every data that will comes in, it will get fit into either of those subsets. But whichever it is not there, that will be considered as an anomaly. So it requires to here the anomalies tend to require fewer partition because of their unique characteristics. And why, in which one it will be effective is for large scale anomaly detection tasks, this isolation forest will be useful. And LOF measures the density of the data point relative to its neighbor. So this you can imagine like a graph. In the graph, you will have like the point data, point related data, and where the points the density is significantly lower than that of a neighbor. So there it will be considered as an anomaly. So this is ideal for unusual activity in the cybersecurity logs. So this is the standard for the cybersecurity. If it is slightly deviating, that will be falling under that's an anomaly. And robust variance is a statistical method. It identifies deviating from a multivariate distribution. And one class support vector machine. So this technique uses decision boundary around the normal data points in high dimensional space. So points, so here you will be like, it's a supervised one, because here it will be like you will feed the data, label the data, and it, points outside the boundary will be flagged as anomaly, and it is useful for scenarios with limited anomalous data such as rare disease detection in medical data sets. And one class SVM with SGD. This I'm not familiar actually, to be honest. Stochastic gradient descent, I'm not familiar. K-means clustering. So K-means clustering groups the data into clusters. So imagine like there will be like a bunch of data, and it will process and it will group it into different clusters. Okay, and the points far away from the cluster center are generally considered as the anomaly. And then LSTM, it is also a little complex one, complex algorithm, and it is like a recurrent neural network. Okay, it learns temporal dependencies in sequential data. Here, we generally use it for monitoring the server logs, network traffic, stock market fluctuations. So recently, we had like this network traffic analysis, or like an say in the telecommunications, we all use internet, right? So in the internet, what will make a customer happy? So we may get like this network glitches, as it happened some time back. Network glitches we all used to happen, but one thing is like if a customer could be given a notice saying like this is an outage that is expected, or this is an outage. Sometimes there will be like a lot of cables, right? There has been like a fiber cut and but if we could send the message proactively to the customer, that will give them a little more job satisfaction. Like, okay, so 8 o'clock, this has happened to end, and so that they all get. Now without internet, the life, I don't know how it will be. Even if it is like no Wi-Fi, it is considered like the day did not even exist. That's how we are all into this complete internet world. So we because we deal with this broadband networks, right? So we generally brainstorm ideas to improve the customer satisfactions, customer serviceability. So in that, consider a Wi-Fi network. In that Wi-Fi network, now we have power backups, but earlier Wi-Fi will not work if there is like a power shutdown. See, that is one behavior wherein the customer will not have the access to the internet. But if you think of other ways, if there is like a fiber cut that has happened, or if there is like some pole damage that has happened, that time also the customer will not. So we have to differentiate that, right? So it is not like whenever the customer has a problem, we can send the notifications. We have to determine which has caused the problem. So there, recently we have introduced this AIML to detect the pattern based on what exactly. So it will continuously give this tracing, and then based on the outcome, it will detect what exactly the problems, and then give the message to the customer, and then the technician should also be sent. So in the formal case, it will not be like a technician needed. It's like the power shutdown. But then in the later case, a technician has to be sent to the spot. But it's moving towards a trend, like it is not like a customer has to comply only, then the telecommunication team will know like there is a problem. No, before even the customer complains, we can know the problem because of this tracing that has happened, that will happen, and then the learning that these models are doing. Okay. And then the robust angle based detection. So here it is based on the angles between the data points in high dimensional space that will detect, that will flag the anomalies based on the deviations. So these are some of the common techniques. And based on this, the programming languages will also differ. So just for your visual purpose, whatever we have seen in the isolation forest, whatever we have seen. So you could detect the anomalies. So this is how it will work. It is like a tree kind of structure. And in local outlier factor, there will be like a data points. It will be like in-layer, outlier. It will give the score as in-layer score, outlier score. And one class support vector machines. So there is like a boundary. And then the decision function will encapsulate the target class in that space. So basically that will determine whether it is a normal behavior of the data or not. And K means clustering, it will group the data. This is little complex, please don't get into it. Okay, moving on. So examples of this algorithm types. Isolation forest is used in detecting fraudulent transactions in credit card data using an isolation forest algorithm. So this is a good example is the credit card data transactions. See, now if you see, even if it is a credit card or even if it is a debit card, sometimes if we do like a overswipe, or even if you use it in a Google Pay, like a limit which is not in your, every month beginning, we all used to do a lot of transactions, right? And sometimes we used to get a call from automated call from the bank saying like, are these legitimate transactions? Press 1 if it is a legitimate transaction. So that is because of the pattern of our spendings, it will keep training it. And sometimes when it is like a deviation, we get the confirmation call. And yeah, LOF and user activity logs for cybersecurity, predominantly to avoid the hacking. And robust covariance, sensor data in manufacturing process. In manufacturing process also, they manufacture like even machine can make mistakes, right? So for doing like the sensor process in the manufacturing units, robust covariance is used. Yeah, this was I was mentioning, right? One class support vector, we used it in the abnormal network traffic in the IT infrastructure. And SGT, it is used in e-commerce, customer behavior data sets. I believe this is for the patterning or then the prediction analysis based on our usage, the advertisements and all those things. K means clustering, identifying rare diseases in patient medical records by analyzing cluster distances. And then LSTM for the stock market fluctuations, and angle based. So here it is more towards the genetic engineering. So the key inference of these anomaly detection techniques is like the choosing the right algorithm depends on the data set, scale, and application requirements. That's very much the key. What is the practical workflow for anomaly detection? First thing, data pre-processing, handle missing data, outliers, and normalizations. Everywhere data normalization is very important. And algorithm selection based on the data and the problem type. What is the problem we are trying to solve? In IT industries, we used to say like, if you could narrate a problem well, or if you could write it down well, that's like half solved. There is like a law as well related to that. If you could write a problem clearly down, there itself it is. I used to follow this for everything. Write it down, step by step, write it down, one by one. If we could check it, it's solved. But then the problem type is also should be clear. And model evaluation using key metrics. So there are like a lot of key metric assessments. F1 score, I don't remember the other things. So based on that, the models will be evaluated. We cannot do the evaluation manually. There are some key metrics for evaluating the models, and deploy the model and monitor its performance. So that is very important, monitor the performance. So this is about the application techniques. The next thing I'm going to go to the case studies. But before that, any questions? Stop sharing for a while because for case studies, I have to go to another slide. Case studies I have selected in my domain only, the one which we have sometime back did a lab big project. So based on that, I would like to explain you a case study. Okay, let me go to the case study. I'm sharing another slide. Please let me know once you are able to see it. Can you see the second slide? Machine learning for anomaly detection. One of you please respond. Am I audible?
Yes, ma'am. Yes, ma'am.
Okay, thank you, ma'am. Okay, so machine learning for anomaly detection. Let me go to the second slide. Home security. So from a cyber security, so my core domain is GIS, Geographic Information Systems. So we call it as like geofence locations. In the CCTV, we all use CCTV, right? So one problem statement I have given to the team is like, in the CCTV footage, if you see like, it's very hard for us to locate. See, CCTV, we know like, okay, what has happened or what is the day-to-day, if my child has arrived, that and all, we can actually see it. We know like 7 o'clock my child will arrive, we will see it, we will know it. But then the problem statement for this one I have given to the team is like, if I wanted to know that there is like an anomaly that has happened. What like there is like an unwanted situation or undecided like theft that has happened in the home. Okay, there was a theft that has happened in the home, and then we need to know who has actually come into that premises during that time. But we do not know when did that person comes. There is like a theft that has happened like 3:30 p.m. for example. Probably that person would have arrived the day before, even like morning or just like 3 o'clock, because the apartments nowadays are like so big, right? The gated communities and everything. So my question on the table was like, how do you identify, okay, this is the person? I mean, I need not go through every frames of my CCTV footage to understand when this has happened. I need a model like it should locate a red car crossed. If I give a statement of that kind, like from a natural language, it should process it and say like these are all the footages of the red car. Like here we have this image recognition. We have introduced that, and then sometimes even in the home, if you see like there are many homes which have this CCTV installed. We used to tend to forget things, right? Where did I keep my remote? Where did I keep my wallet? If I have to search it, can this CCTV help me? That's the problem statement. And then we used this supervised learning on labeled attack data. Supervised learning in the sense, the second part of it, right? Where did I keep my remote or something? So we trained the model with some of the important objects in the home. This is what it is. That's how the initial learnings we did. We made it to the team. Sorry, to the model, and then persons as well. These are all the known faces. Okay, so if this person has entered, this is known. So the problem, I mean, how the input we will give it to the model is like an unauthorized person who has entered the premises. So it will scan through like all the faces. If it is like known, it will just give the unauthorized person alone. Like in around 2 o'clock, there is a footage of an unauthorized, or it may be more. I'm not saying like only it will directly give us the answer, no, but it will reduce the list. It is not like it has to be like the entire footage I have to go through, but it will give me like at least a reduced span wherein I can actually go through the things. So we were able to achieve 90% accuracy in this. And then when we say the object, like a known object, it will keep scanning for it, and it will say like at last when did it scan that object, around 2:30 when it scanned that object. Of that kind it was able to give. And then we made this. We were able to make a little of 90% accuracy. Definitely we were able to achieve. So this is one example. And then from a network security. Okay, so the problem here is like a large telecommunication company to detect anomalies in the network traffic. So because frequent false positives is another big challenge. Whether it is, even we get like a lot of alerts, whether that alert is real, whether we should act to that alert, which one is false positive, that and all is again a separate topic. Okay, it leads to sometimes wasted resources, difficulty adapting to the evolving nature of network traffic, limited ability to detect unknown threats. So that's the problem. And the solution is like to adopt a machine learning based solution to enhance anomaly detection using unsupervised learning and supervised learning techniques. What are all the data? So the first thing, as we have seen in that process, collect the data, right? Network traffic logs, source IP, destination IP, packet size, timestamp. And then what is the defined volume of that? What is the connect duration? If this is like a defined connect duration for this particular customer, it is valid. And what are all the different protocols? In telecommunications, we have like a lot of protocols. What are all the protocols that are used? And then normalizations. Every data as we see has to be normalized, right? To handle larger variations, it has to be like a scaled features. We have used autoencoders, neural network-based approach for unsupervised anomaly detection, and clustering algorithms like dbScan to identify unusual patterns in the high-dimensional data. Implementation steps is, first, it has to be trained. First, the model has to be trained on the historical normal network traffic to learn the typical patterns. Yes, this is normal. But then real-time analysis the network events that deviated significant from the learned patterns were flagged as an anomaly. Okay. So feedback loop, analysts validated flagged anomalies. So here, even if it detects like a flagged anomaly, before we put a system into production, we used to validate it, right? Improving the model over time by retraining the labeled data. So the results are improved detection accuracy. So it could identify 30% more true anomalies compared to the rule-based system. False alarms decreased by 40%. Adaptability, the system dynamically adapted to new traffic patterns, identifying previously undetected anomalies. Sometimes if it detects an anomaly and we say it as like, no, this is valid, we know, I mean, there will be engineers who will be doing like a lot of analysis and say like, this is valid. And that is what will happen in the cybersecurity also. In the cybersecurity, if we get an email, we can report it as a phish. There will be an option in the Outlook to report it as a phishing, because we do not know, right, from an external system, which one we are supposed to reply, which one we are not supposed to reply, we do not know. So sometimes we will report it as a phish. If you click on phishing, it will go to a directly like a cybersecurity team, and they will analyze it and they will immediately respond to it. See, here it is again like whether it is like a DDoS attack or whether like one user that is being impacted. And sometimes in cyber security, cyber threat, it is like first it will come and then it will get access to all the data that will be analyzed by like a cyber security engineers. And sometimes they say like this is valid. this is valid, and at that time it will be, the system has to be adaptable. It has to be adaptable to identify the new traffic patterns and incident response. So because of adapting to this, faster identification of DDoS attack and compromised devices led to a 50% reduction in response time. So challenges: insufficient label data for supervised learning. So, but this, for how the solution challenge was overcome, this it leveraged unsupervised learning initially and gradually built a labeled data set with feedback. Another challenge is high computational cost. Cost is actually a major problem in majority of the IT solutions. Okay, so sometimes one option is to go on a distributed platform using cloud-based resources, but there are other cost containment strategies always that used to come into picture when we have to build solutions of this kind. So the key takeaways: machine learning can significantly enhance the efficiency and accuracy of anomaly detection in network security. A feedback loop is crucial for continuously improving the model performance. Combining ML techniques. So this we have learned, right? Autoencoders is one ML technique, clustering is one ML technique. Combining those provides robust detection, and it can be replicable in other domains also: finance, healthcare, manufacturing. So these are the two case studies. Now let me go back to the full slide. So the resources for learning, I say like there are plenty of resources for learning about AAML. One example, simple things, is this anomaly detection. Hope you are seeing this third slide, right? Resources and further learning. Algorithms by Agarwal, machine learning by AAML at IIT. So this is like the IIT is offering a lot of courses. Even many of our employees are taking this 9 months course at IIT, and the data sets, we have actually data sets to train the model also, UCI machine learning repository, but there is like a lot. This I have given as an example, but there is like a lot of resources and further reading. It's everywhere. We can start from the basic. People, if at all people whoever is new to machine learning and AI, you can even start from the very basics, but that's like a vast to learn. So this concludes my presentation. Any questions, feedback? Amita ma'am. Whoever is the moderators, I'm done with my session.
Any queries? Any doubt and clarification from the participants? Meena, check the chat box.
Sorry, ma'am.
Check the chat box.
Yeah, sure. Yeah, thank you for the feedback, ma'am. Is it good for doing PhD in cybersecurity in deep learning? Definitely, yes. I'll definitely recommend for that.
Ma'am, can you just say any real-time examples where deep learning is used in cybersecurity?
Sure.
Meenakshi ma'am, are you able to hear me?
Yeah, I can hear you.
Can you tell us any one cybersecurity examples where machine learning or deep learning will be used? Any real-time examples? Where can I go and find out? Ma'am, you are muted.
Meena, unmute your mic.
Can you hear me now?
Yes. Yeah.
Yes, deep learning in the cybersecurity is with respect to the DDoS attacks, I'll say, like, because there it's if you consider this organization and all, there will be like tons and tons, tires and tires of infrastructure, network infrastructure, I'll say, like. We'll have multiple data centers, and even in multiple data centers, it will have different security levels installed, and then each of the things there will be like a lot of different threats, and for that the deep learning it should go through a different neural networks. So to have this DDoS attacks and then the global attacks, it will be useful. Just a moment, ma'am. So data set collections, there are some online sources available to feed the data models that you can check. Can we use federated learning instead of traditional machine learning to address cyber attacks? I don't understand what is that federated learning you're talking about. Can you give some more context?
Federated learning is an advanced version of traditional machine learning. Actually, in traditional machine learning, we have historical data for analysis and all. Now, when the data, there is a possibility of data breaches in traditional machine learning. So, federated learning, we are training we are creating the local models in different healthcare centers and all. Then finally, we are creating the global model in the centralized server. Instead of transferring the data between the client and server, we are transferring the model or learned parameters like and all.
Yes, ma'am. Actually, if you consider this future of in cyber security, the future of AIML, there is like a separate topic. In that, I believe these concepts will come in because of the even in the network. If you see, like, we cannot read the customer data. It will all be like an encrypted data is what will be passed through. Every data, if it has to be exposed to all the models, that will definitely be like another threat, right? So there are approaches that is now coming, like wherein you can use this crypto, lot of this encryption decryption mechanisms, right? With that also we can actually train the model. That's the next evaluation. I see I see it. That may be true. I'm not sure about this because cybersecurity, I like it a lot. I used to listen, but I'm not sure about it. Presentation if possible. Sure, ma'am. Yes, without explicitly exchanging the data samples.
ஏய் என்னத்துக்கு ஆட்டுக்குட்டி கத்துது?
Any other questions?
Rajesh sir.
Yes, good evening, madam.
Good evening.
Yes, how we can choose which algorithm is suitable for anomaly detection? The anomaly may be differ for each application. How we can choose which one is best?
Ma'am, I feel like it is based on the data only, ma'am. Based on the data, based on what we look for, uh, and then some previous examples. So when people comes and asks us, I mean, when the employees comes and asks us about the detection algorithms that they have to choose for their projects or for the models they built, we generally respond to them based on what has been like a proven thing in the past. Because for network, this many data it will come in based on the usage, and then the decision algorithms that we need, we used to select. So if you go through each algorithm will have it like whether it is supervised, unsupervised, whether it is like a semi-supervised. So you will have like a problem statement on your hand. Like, so in your problem statement, if you can label the data, then it can be like supervised. If it has to be like a lot of levels of things it has to go through, then it has to be like a deep learning method. And then the inferences we are getting out of it, if it has to be like a data visualization, and the decisions we are going to is for like a small scale, then that it will just decide the algorithms. So it depends on a lot of factors, ma'am. But then whatever the approach methods we have seen, like, so each algorithms you can categorize it, put a problem statement. I mean, we generally do it using the brainstorming sessions, like put a problem statement, and then people used to say like what has worked in the past, and then finalize the algorithms, or else like a proven methods that has been in the market that we will use.
Ma'am, good evening, ma'am.
Thank you.
When it comes to images and when we are planning to train the system with images, which algorithm will be better, ma'am?
Image recognition, yeah, we have used that SVD, ma'am. So because in the because in the CCTV example I have mentioned, right?
Yes, ma'am.
There we actually use image recognition, because in the CCTV it has to determine the object. It has to scan it, and then only it has to determine. So there we have used that SVD.
SVM, support vector machine, ma'am.
Yes.
Ma'am, when we try to use that, the more of the comments which comes immediately is it is the oldest algorithm, and why do you still stick on to it? That is what people say whenever we say it is SVM. So any other better algorithm now, like newer algorithm or anything, ma'am, for this?
I'm not sure. When you say people say, who's that people refers to here?
Ma'am, in the sense if we go present it, or maybe a DC member or anyone who is just listening to our presentation or anything.
Oh, okay. No, but in the real world, in the IT industry, when we have used that algorithm, and it is useful.
Fine, ma'am. Thank you, ma'am. Thank you. Thank you.
I mean, one thing even we say to the employees as well, right? Upskilling is fine, but then proven methods are also fine. I mean, we can start, whoever has asked in Navita, I believe, right? So we can start with the basic model, but then we have seen, right, we can even combine the algorithms at a later point. Once you have like a proven
maybe a hybrid algorithm also.
Yes, hybrid algorithms we can definitely use proven. So, and then when you train the model, when you have the decisions, at that time you will be able to understand it a little more. It can evolve. Every process can be evolved. So it can be like a step by step.
Fine, ma'am. Thank you, ma'am. Thank you.
Thank you, ma'am.
Navita, ma'am.
Hello.
Yes, ma'am.
I'm Sasikla. And how can we find the thread in real time, ma'am? If the data set is present, means we can train the models using algorithm. Then how can we find in real time?
Your problem, I mean, your question is about how do we find the data sets real time? I mean, how do you get data sets for training the model?
No, ma'am. We have to use the algorithm to find a thread in data set, ma'am, using the data set. But in real time, how can we find the thread without data set?
Without data set, I mean, you will, at least you will know, right, ma'am? This is how, see, if you have like a problem statement, what are all the potential data that will be evolved, included in that project is something it will be known, right? It will not be like a, so if you do not know the data, then I recommend like first you have to start preparing your data stuffs. What are all the data that, I mean, in the second example we have seen, like first thing is identify the data that you can actually accumulate, even for the in layer and the out layer. So we have like a lot of approaches wherein you can review some dummy data sets, but then first understand that model or understand the project or the solution you are trying to develop, and start getting the data related to it. Identify the data. Identifying the data is the key, ma'am. Without that, I don't think we have other approaches. But how do you do that? I'll again recommend brainstorming.
Okay, ma'am. Thank you, ma'am. And another one
Also,
question is,
data is available.
can we get the real-time data set in internet or Google anywhere,
Real-time
ma'am?
data definitely you will not be able to get, but then some dummy data, if you look for it, you will get it. Real-time, nobody will actually have their real-time data available in the right. If you ask me, like if you will get the telecommunication network data, then I say like no, we will not actually be exposing any of our data outside. But then some samples of it, and then there are models that will generate the data sets as well. You will have to explore those.
Okay, ma'am. Thank you so much, ma'am.
See, everything it becomes like a security layer in practice, and then the analysis also. It goes hand in hand. The digital technologies, the security, and then automation. So here we used to say like any process, if you can do it twice, automate it. That's the general jargon we used to say like. So automation is becoming key in every industries, every processes. What suggestions can you give to someone who is new in AI and ML and cybersecurity? Please start with the basics. Please understand the basics of what is AI and ML before you dive into deep. Take it very step by step. Cybersecurity is a very interesting domain, and then nowadays we have like a separate cybersecurity courses as well that are like 8 months course, 3 months course. But before that, there are like a lot of learning materials available. So and then the main benefit I'll say like in the cybersecurity is like it is in the day-to-day day. What is cybersecurity? Any securities that will that is needed on the computer and the digital transactions is cybersecurity, right? That what is a cyber threat that happens in electronically devices? All the threats that may happen is actually a cyber threat. So my suggestion will be start understanding the basics, start understanding your real-time scenarios. Whenever you are doing some digital transactions, think about what potential threat this could happen, and then read through the materials and slowly come to AAML. First start the cybersecurity and then AAML, and then attend this faculty development program for 6 days. You'll get more knowledge on AAML and cybersecurity. At least the basics, I believe you all will be able to get with the 6 days program, because they have nicely framed the courses based on that.
Next question.
You're welcome. Ma'am, is there any other session at 8 o'clock, ma'am, today?
Yes, we have next session.
And I have given my LinkedIn address and details to Amuda, ma'am. So PPT, yeah, PDF file is available with the ma'am. You can take that as a reference.
Okay. Thank you, Meena.
Thank you
Is
very
there
much.
any feedback session now? I am so happy to have you, Meena, here because in your busy schedule, you can accept my invitation and spend your valuable time with us for a wonderful session. And also, your first session, you started with a good presentation, and your presentation is also good. Uh,
Thank you, ma'am. Thank you for this opportunity. Um, you are all really great, making the students to learn. I mean, when we get interns hired, I have interns hired from Tech College. I have interns hired from National Engineering College. Lot of, but then please give them real-time practical examples, and then that will be helpful for them when they come into IT industry. Okay, so you are all making our jobs easier. So a lot of kudos and appreciations to all the faculty members present here, especially to Amuda ma'am.
Thank you. Share the feedback. Share your feedback link now.
Ma'am, it is asking for permission, ma'am. If you click on the feedback link, it is asking that permission is not granted.
Okay.
Ma'am, do I have students also joined here, ma'am?
Research scholars and
Okay.
university, engineering college faculty and arts college faculty.
Okay.
That's professionals.
Okay. A big thanks to all the faculty members there. Okay, I'll see you all in the day 6. There is one more session. Looking forward meeting you all.
Maithili ma'am, give.
Yes, ma'am. Thank you, Meenakshi ma'am. I would like to extend my heartfelt gratitude to Meenakshi Sundari ma'am for taking the time to share your valuable insight and expertise. Your presence has truly enriched our gathering, and thank you for your enlightening talk and for inspiring us with your remarkable journey. I would also like to thank our organizer, volunteer, and everyone present here. Thank you once again, and let us continue to learn and grow together. Thank you so much, ma'am, for your wonderful session.
You're welcome. It's my pleasure.
Thank you, Meena.
Bye.
Thank you so much. Share the link in the chat box, sir. Feedback link is shared.
Madam, try to share in the group, no, madam. Better.
Lizzie, ma'am.
Yes, ma'am. Shall I continue, ma'am?
I'll check, ma'am. Okay, and then
Okay, ma'am.
I'll call you.
Okay. Okay, ma'am. Okay, ma'am.